sent you this link. You can open the link which I have shared in point number 3, right? The person is Anders Brownworth. I think he used to teach in MIT. There was a course. I don't know currently it is live or not on blockchain. So let us try to understand it again. I will discuss some part of it during the slides, but it is always better to understand kind of from here, right? So let us first click on this hash. Right. Uh, so hashing, just think of in this way, right? If I want to hide something, like, am I audible?
So your voice is breaking a little bit. Can you please bring your microphone a little bit closer to your mouth? Not really easy.
Am I audible now? Is it better?
Yes, sir.
Yes.
Yes, sir.
Okay. So think it has in such a way that if you want to hide something, right, from the public, or if you want to, so the process is called encryption and decryption, right? Cryptography, right? If I want to like kind of secure the message, any kind of information, right? There are different cryptographic algorithms available, right? We'll not get into the how the algorithm works, so that is not the agenda. But just to understand, there are different algorithms, right, or the programs, right, which can make anything you write or any information you put into a based upon the algorithm you are using, right, into a cryptic message, right? Be it a simple random number or mix up a kind of a alphanumerical, like kind of alphabets and numerics will be there, right? So if I write here my name, right? Okay. There are obviously a mix of small and cap letters here, right? So I have got a hash out of it, right? So then I realize, okay, I have made a mistake, then make it capital. So if you see every change I am making, there is a change in my hash. That means any information I put here, the hash formation will be very unique, right? So if I just write down my name, use this, see there will be a specific hash for it, right? So like I said, there are different algorithms. SHA is called a secured hash algorithm. SHA, secure hash algorithm. Right? 256 is basically 256 bits that will be converted into 32 bytes. So what is unique about this? If I write a single letter, okay, or I just copy paste like kind of any amount of information, right? So I wrote a single letter, the length of the hash, right? Or if I just write all the students who are available here, right? So the length of the hash will be always 256 bits or 32 bytes, right? Each byte is around 8 bits, right? 32 into 8 is around 256. So that is the idea about it. I can write a complete copy paste a book here also, right? I think that is the size of SHA 256 can around 2 lakh terabytes. So don't worry, I can download all the movies in world and upload here. But at the end, it will give me a fixed length of encrypted data, right? So this fixed length of encrypted data, a mix of alphabets and numbers, that is known as hash. Yes, Swagat. Go ahead.
Sir, simultaneously what you are doing, I am also doing by splitting my screen. But sir, the way you wrote your name, I also wrote my name in that way, but it is not showing any error.
It is showing error.
No, not showing any error. So like
So
the way
it won't show any error, right? There is nothing.
Grammarly.
Okay.
It's a
Okay.
Grammarly.
Okay. So I have yeah. So I have installed a software called Grammarly that checks grammatical mistakes. So that is different. That is not part of this.
okay, sir. I
That
thought
is yeah.
it will
No.
so
No. This is only converting a data set, right? Whether it is a small or big data set. The uniqueness of this algorithm is, or the like kind of similar kind of algorithms is, it will always create a fixed length of encryption. That means no matter. So if I can write whatever here, or if I can upload a movie also, right? I'll send you a link where you can upload up to 10 megabytes of data, right? And you will see yourself. And first part is it will always give a fixed length of encryption. That means 32 bytes or 256 bits. And that is the name why SHA 256 can. Second is every time, let's say if I write my name here, okay. So obviously you cannot remember all the names, all the like kind of digits. Just remember the first 4 digit, 80C9, right? So every time I give the same input, right, the output will be always same, right? So that is the second part. For every same similar units, not similar, same input, right? If I make a slight change also, the output will change. For the same input, output will be always same. Second, it will be always a fixed length. Yes, go ahead. There are a few questions, I guess. Sagat, Alisa, and who else? Ashwin. Yeah, one by one.
Sir.
Yes.
Sir means 80C9 will be same for means whatever we write, or
No,
it will
no.
be different.
If I'm writing my name, if you write your name, right? Uh,
Yes, sir.
the whatever it is not about ATC9. Whole digit what I'm putting here, whatever it is converting, it will always remain same. If you write whatever your name is in that space, the encryption part, whatever that encrypted final encrypted output is coming, that will always remain same. If you are using a SHA 256 algorithm. Yes, Alisa.
Sir,
Sir,
Yeah. Yeah. Yes, go ahead.
sir,
Go
sir,
ahead.
can
how
you
is it?
please
Okay, Astrid, ask.
One by one, one by one. Yeah, go ahead.
Sir, how is it different from encryption? I mean, hashing is how is it different from encryption?
It is same as encryption only. There are two parts, encryption and digital signature. Hashing is nothing but encryption cryptography, part of a cryptography algorithm. So hash means the output you are getting is known as hash. So this
So
algorithm is
then we
known as,
can then we can like we do encryption and it can be decrypted. Then can we decrypt this too also?
you cannot decrypt it. I'll not say you cannot decrypt it. It is very difficult to decrypt it. With the computing power we have, maybe with quantum computing you can do it. Right now with the technology we have, we cannot decrypt it. So it is a one-way cryptographic algorithm. That means if I give an input, I can get output. But if I give output, you cannot get input. You cannot get, I will not say, it is very difficult to get an input if I give you output. So if I give this output 80 C9, whatever this digits, right? The combination of alphabets and digits, right? You cannot know what is the input. Input is my name, right? But you will not able to get it by using any kind of algorithm which is currently available. Maybe with quantum computing it can be done, but not currently. With output, if I give you output, you will not be able to get the input.
Sir, what is the use of this hatch?
Yeah, that will come. That will come later on, right? So just understand there is something where data can be encrypted by using this algorithm called SHA 256. Okay. Any questions on this? How it is used? Will because that is the basic of blockchain. We'll discuss in detail how it is being used. But just remember there is certain algorithm called SHA 256. SHA means secured hashing algorithm. 256 means the output will be 256 bits or 32 bytes, right? And it is always output will be given by a fixed length of 256 bits. That's why the name is SH256, right? So again, it is an encryption technology. If I give an input, the input data will be encrypted to a fixed length of output, and that fixed length of output is known as hash. Yes, Swagat, go ahead.
No, sir, I forgot to lower my hand.
Okay, okay, yeah. Any other question? Yes, Satyaswara.
Sir, when we input the same data, we are getting the same output every time. Let's say
Correct.
कि you also inputted 1000 INR and I also inputted 1000 INR. Both having the same has both have the same hash. So it might create some problem because both have use the same input, but we having the same hash function.
Yeah, so this is basically I just gave you a obviously if you just want to kind of encrypt your name Ashwini Naik or Satya Swarup, right? There are many people named Satya Swarup in this world, right? Every time if I just put a
Yes, sir.
word, then somebody can hack it, right? But in blockchain, that is not only the idea, right? It is not about putting 1,000 rupees or 1,000 Bitcoin to another account. There are a lot of other data associated with it. They are also encrypted. So it's a mix of that.
Similar for
Yeah.
name also.
Yeah.
Similar for name also. Matlab, I just say 1000 INR. Similar for name also, we have same name. There are many common names, so that can be again a problem.
So you should have a, so it is basically, so in blockchain, it is not your name. Name will be converted into a, again, using some cryptography that will be changed to a some hash, right? That has the transaction details, timestamp, the person you are sending money, what else? The person where you have got the money, right? Those addresses. If everything matches, which is impossibility, then it will be sent. So the what I
Okay.
mean to say is, it is not only your name or the address, the amount of money you are sending. There are around 6 to 8 different kind of data, right? All those gets encrypted together, right? Being
Okay.
all of them same is kind of a impossibility, right? Okay. But again, like hackers can try to do it. I can assume your identity and try to send something, and that will be prevented with the blockchain technology, and how it is, we'll discuss that. Yes, who else? Shreyasi. Shreyasi, then Ankita.
Yes.
Yeah.
Yes, sir. The length of the hash does not depend on the amount of data we have entered. Like if we enter large volumes of data, like you entered a data set of students and roll numbers, but the length of the hash remains same. So does that depend on the input data, or it does not depend on that?
Yes, obviously, it depends upon input data, but in input data, they divide into different blocks again. Each of block, there are, I think, 6 to 8 stages of encryption, right? So they try to encrypt it, still it reaches that fixed length of digits or mix of digits and alphabets, right? It obviously depends
Yes.
upon the input. Like I said, otherwise, if it doesn't depend, right? What happens every time I give the same input, the output will be different. It obviously depends upon the input, but the idea is the final output will be always, the algorithm is made in such a way that final output will be of that fixed length. There is something called SHA 512, also 384. So again, depending upon what algorithm you are using, that will be of that length. Yes.
Okay, sir. Thank you.
Who else? Ankita? Ankita, then Alisa.
Yes, sir. So there are apps named as cryptographer. Sir, they are newly launched. So what is the idea behind it? Means, so what is the work they are being performing?
Did not get you. Can you please repeat your question?
The cryptographers are the apps that are being launched newly. Sir, what is the idea behind? Like, what is the reason why they are being used?
So you are talking about the cryptography or cryptography app? There is some app called cryptography.
Yes, the cryptographer that apps are known as.
No, I'm not aware of that app. If I come to know, I'll let you know. But if you are asking about cryptography, again, this usage is to so that other cannot steal your identity. It is hidden from the public, right? So that is the idea. Yes, Alisa.
If it's a new beginner to all this thing and he has entered, like I have entered my own name, Alisha Nanda. So there are many Alisha Nanda all across the world. And if somebody is trying to hack my account, but the name remains the same, so how will he distinguish? Because I don't think there is any difference if this Alisha or any other Alisha, the hash code remains the same. So how do we distinguish that thing? So how will
So
he
I-
Yeah.
distinguish? And
Okay.
There will be a lot more data in there excluding your name, right? So
Yeah.
I'm
you
not
have to exactly know.
Yeah, but Alisa, let me answer your question. So that is not a simple single digit. There is something called private key and public key that we'll discuss
public.
later on. Okay. So
Okay.
that is a different algorithm, right? So the basically this blockchain uses two kind of algorithms. One is SHA to keep transactions or the data like kind of in a short form, right? Rather than, let's say, if I upload a movie or if I want to send a movie to someone else, right? And I want to authenticate
Yes.
that data, right? I can do this by hashing algorithm, right? All the transactions, right? Every now and then, maybe not millions, there are 10,000 transactions happening across blockchain network, right? Writing all of them, the database will get filled, right? So one of the usage of this algorithm is it shortens the amount of space it takes, right? But to answer your question, yes, definitely, Alisa, if you have certain cryptocurrency in your account, right? There are many Alisas, right? If I say that, okay,
Yes,
this
yes.
is your identity, that is not true. Whether you are using a cold wallet, hot wallet, you will be given a private key. If you lose that, definitely
Yes.
somebody can hack. But if you do not lose that, that unique number will be very unique to you, right? Nobody, unless you
Yes.
share it with others, nobody can know. How it is done, we'll again look into that. Yes, who else?
Yes.
Swagat. Yes, Swagat.
Sir, sir, these 256 bits are the outputs, sir, you told. Sir, this output will be shown where? In this hatch column or where? This 256 bits. So 256 bits in the numbers or the digits or what we can call it.
256 bit is the 0101 like that. So one byte is basically 8 bits, right?
Sir,
So,
yes, sir.
so 32 bytes are 256 bits.
So, sir, whatever result it will show, it will be in 256 bits.
Yes.
But, sir, if we see in this screen, there are no 256 digits. There are
That is not
around
256 digits, that is bits. So every digit will be converted into a 0101, right? So those are the bits. Then 8 bits form one
so
byte.
where that will be.
Where?
So that 0101, where we can see that. So it is, or it will be hidden or something else.
So it is the computer kind of a input, right? Whatever. See, computer cannot read this F7 to computer doesn't understand that, right? Computer understand
Yes,
only
sir. Yes.
01, right? So that is the like computer input 0101. So this number, if I convert into a computer, the computer readable format, that will be 256 bits. 011010
Okay.
like that, it will be
Okay.
256. But obviously I cannot
Got
read
it, sir.
that. So it has got converted to our language, right? I can convert this into Chinese also, right?
Yeah.
Those people who are working in China, right? It will not be in English, it will be in their language. Obviously digits will be same, but alphabets will be different. Okay. So
Yes,
now
sir.
let us understand how it is has been used in blockchain, right? So like I said, block is nothing but a, like we discussed in earlier class, right? When we talk about block, it is a list of transactions happening during the previous 10 minutes or half an hour, whatever the time limit, right? Or few seconds, right? Different blockchain are following different time limit. All this data here means all the transaction. Let's say what I'll say Ankita sends money to Alisa INR 5,000, right? Let's say this is a transaction, right? Like that, there will be many transactions, thousands of transactions, right? So that constitutes of, so number of transactions. Again, each block won't have a uniform number of transactions. Within that last 10 minutes, number of transactions which has been validated, verified by the miners, right? That will get into this data part, right? So data is nothing but the collection of transactions, right? The list of transactions, right? Block, this header is shows the current identity of that block. The first block will be the block 0 or the genesis block. Just imagine when like Bitcoin or Ethereum or any cryptocurrency has started, right? There will be always a first block, right? If you search on Google the block 0 of kind of genesis block of Bitcoin, you'll go there and find out the address who has created that. He'll just get a hash of that address. By knowing that address, nobody can know who is the actual person. But they know that okay, there is a person who has created that block, right? And he has got around 50 Bitcoin for that, right? So imagine a block is a list of transactions. Data is nothing but those list of those transactions, right? So like that, if I put whatever transactions, so details of transactions, right? So the hash will keep changing, right? So what basically blockchain is doing, it is taking those transactions and converting all the transaction list of transaction into a encrypted message, right? And that is that hash. The output is a hash of 256 bits, right? So this is the first use of hashing algorithm, right? All the list of transaction across any block which is happening, right? So that is the getting encrypted, and that is known as the hash, right? Is this part clear or any doubt?
So your voice is breaking, sir.
Am I audible now?
Yes,
Hello?
sir.
Yeah. Yes. Is this part clear?
Sir, the basic difference between the hash and the block is hash is a single input thing, and block is we have a number of transactions or multiple set of data that is verified by miners in the
Yeah.
last minutes.
Yes. So hash is a kind of a signature or a hash. If I combine, hash is the identification of that block. If I give this hash, right? So people will know that okay, this is block number 1, this is block number 2, right? So if I like think about your home address, right? If I say that okay, you stay in that, there is a single number to identify your address, right? So hash is nothing but that. If I know this, because this will be unique to all this block, every information which is involved in this block, right, will get converted to a single this output, right? So that is the hash.
Yes, sir. Sir, वो जो ऊपर में there is block hash one. The hash one is the name मतलब serial number of the
Yes, yes, yes.
and
So,
what is nonce.
yeah, we will come to that. What is that nonce we'll discuss here and in the next part in the block.
Yes, sir.
So here, yeah, one by one, one by one. Yeah, Samrat.
So firstly, I would say that my Zoom was crashed for my attendance as well. So that time you were saying I couldn't just like do anything. So Zoom wasn't responding. The second
What's
thing, sir, I wanted to ask,
roll number?
272, sir.
Okay, yeah, go ahead.
Sir, why are we using SHA algorithms instead of, sir, any other simple asymmetric cryptography algorithms such as RSA or any other transport layer encryption which is available in the
I
market?
think most of the times, or kind of SHA is only for the Bitcoin part, not all. I think in Ethereum they use something called KECK, KSEC 256. So SHA 256 is only for the Bitcoin part, and because it started, everything started with the Bitcoin part, right? So I just showed that example. So to answer your question, why it is used, because I said like kind of in that paper, white paper, it started with that algorithm SHA 256. Whether blockchains can be utilized using other algorithms, obviously yes, there is no doubt about it.
That any form of asymmetric cryptographic algorithm
Yes,
should
yes,
work.
yes, definitely.
And sir, to be much more precise, sir, it has to be something of a message digest algorithm because all the input data that we are giving, it's
These are
digesting into a
yes,
metaset and then
yes. These are all message digest algorithms, right? Even SHA 256. Any kind of message digest algorithm will work. Again, depending upon the security level which you want. I can use SHA 512 for my blockchain. So again, like that was a good question. What Samrat was asking, whether all the blockchains use this. No, this is one of the hashing algorithm. In this slide also, there are different algorithms which can be utilized. Ethereum itself used a separate algorithm. So just remember, this is a mechanism to encrypt certain kind of data, right? Depending upon if you create a blockchain tomorrow, right? You will say that okay, I am trying to use or I'll use some other algorithm, right? You will are free to do it. To answer the other part of question, why SHA utilized right initially? I guess because the like person who invented or who created Bitcoin, right? He mentioned in that paper SHA 256, and he designed the Bitcoin with that, right? Everybody started continuing with that. I don't see any specific reason why other algorithms cannot be used. I don't, because other algorithms are being used. Yes, in Minhaj.
Yes, sir. So whenever someone is trying to change any data in a particular block, then the hash will change for that
Yes.
block and also the previous. So in that case, since all the blocks are connected in the chain, so in that case, all the blocks in the blockchain system will change, right?
Yes.
I mean, hash of the block. So
Have to be changed. Yes. Yes.
so is in a problem for transaction and all. If the hashes of all the blocks are changed because of one particular transaction.
Yeah, so that is the idea, right? You cannot change that. Once the block has been validated and included in blockchain, unless you have so much hacking power that you have hacked around 60% or 51% of the number of nodes,
Yes.
right? You're not able to do that. So just imagine in a simple way, if I say, I'll give you a notebook, right? I'll give you all of you a notebook, right? It is exactly, it is a digital notebook, Google Form, right? So what happens? Each one of you have a copy, right? Suddenly what Ankita will say, or Alisa will say, no, Ankita is supposed to give me 10,000, right? She will change in her notebook, right? But if it is not replicated across all the other notebooks, right? So she has to make sure that out of 45 students, around 23 students are there who are copying the same transaction, right? If they are, she is able to do that, then obviously it can be done. But again, like there are other difficulties which we'll discuss. It is not about only the present block. Any change you are doing here, right? Your future blocks will also get hampered. By the time you make these changes, already additional transactions has happened, right? So it becomes difficult in each step. But whether it can be done, yes, theoretically, yes.
But so once this hash is generated or the message digest is generated for a given block or any transaction,
Hmm.
after that, so this hash value is immutable. And any change in this hash or any tampering with this would result in devalidating, like the entire transaction would be termed as invalid.
Correct.
Which would be like,
Once it is getting into a block, right? If I want to tamper with block, I should have at least like let's say there are 10 lakh nodes, right? I should have a control of around 5 lakh 10,000 nodes. They can modify those blocks. Then there will
yes,
be a
means
forking.
then the only way to modify the block would be if we have a majority over the
Yes,
entire
yes,
peer-to-peer
that is the only way.
ecosystem.
Yeah, yes, correct. That is the only way.
Okay.
Because like Minajul was mentioning, so I was just answering, it can be done unless you have that much computing power across, like basically divided across world, right?
That is the 51% attack.
That is
51% attack.
Yeah, so basically majority here means the number of like more than 50%, 51%.
Okay, so thank you.
Okay, so right now what we have just only discussed, we have a input message, we want to encrypt it, right? And how it is used in blockchain, list of transactions get encrypted, right? Into a particular output that is hash. So now we'll come back to the blockchain, right? So here what happens, like Samrat or Minhajul was talking about, there are a lot of, again, right now if you say it is 61053, last time we checked, right? The latest block in Bitcoin network, right? Around 6 lakhs or so, around 6 lakhs 20,000 blocks has been created, right? So if I go here, this is, let's say, the first block, right? Every block, whenever it gets created, right, there are a few things which get encrypted, right? The data what we put here, right now everything is blank, right? Then the previous so hash means what? Like I said, every information in that block get converted into output 256-bit data, right? It's certain length of data, right? So in the block one, what happens? This is the first block, right? So there is no previous block. So if you see, everything is 0, right? So when I, let's say, I put certain transaction, Alisa to Ankita, 10,000. So any change in the previous block, see all the next blocks get only here. How many blocks there? Around 5 or 6. Yeah, 5 blocks, right?
5.
Everything gets changed, right? So any change if I make in my previous block, in the first block, second block, third block, right? The next blocks here in this case, fourth or fifth block will get corrupted, right? Again, I have to validate that, right? So if I change in the last block, Alisa, so any change, let us not write always the same thing. Whatever changes I make here, right? Only this block gets corrupted, right? Let's say right now I'm just working on this block, right? So the current block gets, again, I have to validate that. But anything I have to do in the previous transactions, right? If I do it here in the fourth block, so 2 blocks gets corrupted, right? Corrupted means again they need a revalidation, right? So that is the kind of, again, the additional bit of security, right? Let's say a transaction has happened and it gets added to any block, right? After 1 hour, you want to make changes to that block or that transaction, right? Already 6 blocks have been generated, right? So if you make any changes to your transaction, right, try to do that, right? Those 6 blocks gets corrupted, right? You will not able to make those changes.
Sir, why 6?
No, so I'm just giving that example because, okay, you are
Okay.
telling why 6, right? Yeah,
Yes,
so
sir.
the Bitcoin right now, or at least in the beginning, design in such a way that, yeah, on an average, again, it is not ideal time. Some blocks get generated within 5 minutes, some blocks take half an hour or 1 hour, depending upon the volume, depending upon the time it takes. But on an average, it takes 10 minutes. So that means every 1 hour, you'll get around 6 blocks. So that was your question, right? Why 6?
Yes, sir.
But
Yes.
again, it is only for the Bitcoin. For Ethereum, I think it is, they take around 10 seconds on an average. Yes, Asper.
Yes, sir.
Sir, if someone changed the fourth fourth block, and someone is working on the 11th block, if someone changed the fourth block, then the person who is working on the last or 11th block will get affected until, like, what will be the 11th block will receive, the before the verification or after the verification one, like the
After
change
this, so, every time you are working on the blocks which has been
not
already
verified.
verified. So if you make 10 changes, it is not verified, right? So that block 11 will be still working on till block 10, whatever blocks has been verified. So if you are
So
able to
what
get
if the block is not verified at all?
which block? Block number 10.
Huh.
Yeah, if unless the block number 10 is verified, you will not get any generation of block 11, right? So the number comes once your block is validated and gets into a blockchain. Then only block, let's say block, right now we are working on block 5, right? So unless it is verified, right, block 6 won't be created.
No, sir, what I'm saying, it's there were the 10 block verified before. What person or one person came and changed the fourth block?
Yeah, so let us try to understand in that way, like notebook way, right? So all 45 of you have notebook, right? So there are 10 pages, right? Think about block as a one single page, right? All the information which is up to 9th page has been same, right? That has been verified and it has been copied across all the 45 students. Right now, what is happening? You are writing on page number 10, right? Getting the information on internet, and everybody is writing on page number 10, right? Now somebody, what some one of you does, he will go and make a change on page number 5. Page number 5 is block number 5. Now what happens? That person who is changing, it is only his or her copy, right? Unless he is able to get a computing power, or at least have a power over all those 23 or 25 students, to make sure that they are changed page 5, 6, 7, 8, 9 within the time block 10 or 11 is getting created. If within that 10 minutes he gets the control of all those 25 or 23 students and made them change page 5 to 9, then it is possible. You got my point? So right now, again, I'm repeating, let's say blocks are pages in your notebook, right? Right now, let's say you have written. So the identity of notebook is basically a blockchain. So number of each page is a block. And each page will have same information, not similar, same information, right? So all 45 of you have the same information till 9 pages. Right now, everybody started writing on page number 10, right? Now what happens? One of you told, "Arey, I made a mistake on page 5. For that transaction, I need to change," right? So you'll go and make the changes in page 5, make some corrections. But that is your own copy, right? That is the blockchain copy of you, right? If you like kind of able to convince all 23 of the other students to make changes in page number 5, but what happens now? If you change page number 5, page number 6 has to be changed, page number 7 has to be changed, 8 has to be changed, the next blocks need to be get changed, right? So if you are able to convince all of them to make all those changes within the short period of time, because what happens within the 10 minutes, if you do not do that, block number 11 or the 10 has created, right? So every 10 minutes, one block is getting created. So if you're able to do that kind of computing activity, or at least negotiating or networking with those 23 people to make those changes, then you will be able to do that. Why you cannot do that? Most time, not most of the times, all of the time, you don't know the identity, who are the miners, right? Identify the exact location and all those things. Unless you have that much computing power which controls the 51% theoretically that much computing power, and within 10 minutes you have that kind of power to change all those previous blocks, right? Then it is possible, otherwise it
Can
won't
we say
happen.
this is a disadvantage for the blockchain?
One way, yes. That I think we discussed in last class. Let's say I made a I made a mistake, somebody made a transactional mistake, it gets added to a block, right? Reversing it is kind of cannot be done. But in some banks, I'm not sure all the banks whether allow it or not. By mistake, I sent certain money to certain wrong address, right? If the other party agrees, I guess in certain banks, the transaction can be reversed. But it cannot be done in blockchain. So blockchain, what will happen? Another transaction has to happen, where the other party will send you back the money. But he or she doesn't agree. It is you cannot do anything. So was that your question? Like if a transaction by mistake you do, whether yeah. So yes, that is a disadvantage. Anything transactions happened in a blockchain cannot be changed.
Sir, sir, one doubt.
Yeah.
Sir, suppose we are making suppose in a cryptocurrency there's a new block is formed, and for a single block there will be like some payments. We don't know how much, but there will be suppose 100 payments. But how do we know that? Is there anything certainty like that after this number of payments a block will be completed and new block will be formed?
No, it is not about payment. Generally, they try to, the number of transactions are happening within the 10 minutes of time, right? They try to make the time as a proof, right? Within this time, number of transactions happening, they will put that into a block. It might happen that in 10 minutes, only 5 transactions. It might happen that in last 10 minutes, there are 500 transactions. So the block size won't be same. Like, and the number of transactions in a block won't remain same.
So then the differences in time, like you said, there sometimes it may be 10 minutes. Sometimes
Yes. So basically, yeah. So basically, it is trying to solve the problem, solving a puzzle. What is that puzzle? We'll discuss now. So every time you want to mine something, there is a puzzle you need to solve. Okay. So again, repeating, what is a blockchain? Blockchain is a connected blocks, right? Each block is a list of transactions. Each block will have the information about the previous block. How it is so? So every block, like I said, when the hashing happens, there are few parameters it is taking into consideration. The block number, there is something called nonce. Nonce is a used ones, number used ones, that is a random number. How it is used, we'll discuss that. Then there is something called the data. Data is list of transactions. In this particular case, if you see the block number 1, right, there is no previous block, right? So if you see in the previous case, it is everything is 0, right? Then right now, what is this mining activity? If I just click on this mining, right? So if you see this number gets changed, this random number, whatever was there, let's say if I make some another changes, A to C, right? Then A to D. Okay. These are the three transactions which has happened from A to B to A to B, then A to C, then A to D, right? Anytime any transactions or any data is changing in that block, right? It needs to get mined, right? What do you mean by mining? Mining is some form of verification, right? How does that verification happens? There will be a rule, right? And the rule is in such a way that the hash you are creating will be of starting with certain number of zeros, right? So in this actually the demo which has been created, the rule is the hash which need to be created will start with at least minimum 4 zeros, right? So how to do that if I do it manually, right? I don't know the exact number which will, so I can do like 203110, 20312, or let's say randomly I put 5, or right. So what basically when you talk about this mining activity, right? All the computer nodes do this kind of number generation. This is known as hash rate. Basically, they are making guesses, right? The hash rate when you talk about, they are making guesses about the hashes, right? So what will be the rule? So in this demo, the rule is, so you try to do that. You write something in the data, right? And change the number here. If you are able to put a number here, that number once, nonce, right? Number used once, right? In such a way that this hash which is created in the bottom has 4 zeros in the beginning. Then you will be able to say that yes, I have verified this block. That is this is nothing but this mining process. This is the like kind of proof of work. We'll discuss that part later. But the mining part is simply is this. There is a puzzle to be solved. What is that puzzle? The hash has to be a start with certain number of zeros, right? In this demo version, it is 4. Currently, I believe the Bitcoin, I think the puzzle is around 19 zeros. The hash has to start with 19 zeros, right? If somebody knows better, can correct me. If somebody has the latest information, as far as I know, that is around 19 zeros. Here in this particular demo, it is 4 zeros. So what actually, if I say I do not have a computing like kind of which will do those kind of, because why we are using computers, right? It will do a lot faster than a person, right? Putting a number here 7, whether it is 4 zeros, right? If I do like that for each doing this, I'm taking around 1 or 2 seconds, right? Computer can do this kind of activity million times faster than us, right? So that's why we need a better computing power, right? So the idea is you are using a random number, right, which will create a hash of starting with certain. So that is the puzzle, right? Hash starting with certain number of zeros, right? So you try to do that. Whether you'll be able to put a number here, which will start this with few like those 4 zeros, right? If you're able to do that, you just manually able to mine there, right? So that is the process of mining. Is this part clear? I'm just looking at block number 1. Any doubt on this?
So you
So,
said hash.
yes,
And
Alisha.
that, yeah. You said that verification will be done in the mining process, and it should start with 4 0 something you said, and there's some puzzle that needs to be solved.
Yeah. So
And
the
then you said
puzzle,
something about
yeah.
19 zeros. I couldn't get it, 4 zeros and
Okay.
19
Yeah.
zeros. Why?
So in this demo, which the person has created, because obviously we do not have that much computing power, right? So he has made it very simple. He has told the puzzle is hash need to start with 4 zeros, right? Because it is a demo, right? But in the actual blockchain, which Bitcoin is right now operating, the puzzle. So again, I'm repeating, the miners to verify the blocks, right? So what is the verification process? I need to solve a puzzle. Okay. As a miner, if I am working as a miner in that blockchain platform, so I have to solve a puzzle. Okay. I have to solve a puzzle to verify a block, right? And if I do it faster, that means if I'm the first person to solve the puzzle, right? I'll get certain amount of Bitcoin, or I'll get certain kind of Ether, right? Depending upon where I'm working, right? So that is the idea, right? Why I'm using that much computing power. At the end, right now, if I solve quickly let's say only there are 46 minors, 45 students, and as a professor I am there, right? And we want to solve this. So you start working on this. You just put A, B, A, C, A, D. Let's see who is trying to do it. Block number 1, right? Manually we'll put certain numbers, right, in this nonce, right? So that is this puzzle. Finding a random number here, right? Finding a random number ones or nonce, finding that number. If I put that number, my hash will start with 4 zeros. That puzzle is nothing but finding a nonce or finding a number which I include into my data that will create a hash of certain starting with certain zeros. For this demo part, the puzzle is if you are able to put a number here, like put a nonce here, which will create a hash of 4 zeros starting with 4 zeros. That is your puzzle. Can you solve that puzzle? If you do it faster than 44 students, you will get certain reward. Similarly, any blockchain works in that, like whoever is using that proof of work algorithm, they are using that kind of setup. If you are able to solve that puzzle, so puzzle and finding that random number are not different. Puzzle is nothing but finding the random number, which is that random number. The random number is this nonce, NONC, right? Finding that number, writing a number here. Once you write that, the hash will become 4 zeros, because every time I'm changing here, right, my hash gets changed, right? So if I'm putting 889, that is single zero, right? So I have to keep trying in such a way that by putting a number here, putting a random number here, this hash will be of 4 zeros, right? Now coming back to, because this is a demo, it is a very simple puzzle, 4 zeros. In actual blockchain, at
So,
least in, yeah. Go ahead.
so if we run pre-merge attacks on this, like supposedly if a blockchain is at the very beginning stage of it, like the first few blocks of the chain is being just created, then so the rewards will be high and the computational power required in order to break through that chain would be less as well, because we can apply brute force as the number of scenarios would be less comparatively to a much more matured chain. So if we can just attack on the very first block, like the block 0 or the block 1 of any given chain, we have a fair chance of getting successful even through brute force. And subsequently, sir, we can move on to much more advanced collision attacks and pre-merge attacks in order to trace whether two blocks will have the same thing or not, like the same hash for same input, or we would be guessing the inputs. And sir, if we can crack a single block like that, won't the next of the chain be very much predictable for us to crack?
So when you say, can you please repeat when you say that by using brute force, what you will do? You will like kind of create this random number.
So we can run a pre-merge attack where we can try to guess the input which was given for the present hash function. And if we can get the value of that, like if through the hash function, we can get our n1s out by predicting it. So will it be possible to break through the other blocks as well?
No, for each of them, there will be a separate image, right? So you have to break all of them.
Okay.
So to answer your question, yes, that is when you talk about brute force, right? If you have that much computing power, right, you are able to do it very much faster, right? And that's why I told it might be possible once quantum computing is mainstream, right? The time it takes to solve this kind of puzzle will be very less. But with this current computing power,
But sir, for the existing blockchain, if we consider this existing blockchain with 3 blocks present in it, it is at the very beginning of its life.
Correct.
The amount of computing power which will be required to break through this chain would be very less. But as we have seen, when like rewards are given out to the miners, people who are mining at the beginning of the blockchain, they get substantially better rewards compared to the pools which are like completely mature now with millions and millions of miners currently working on
that is true.
network.
Yes. So
It's much more
initially,
profitable, it's much more easy.
yeah, so I'll not say profitable, because see, you are not getting bitcoins, right? So right now, if you are getting a bitcoin of some network, yes, obviously it is profitable. But they have their own cryptocurrency, and that value will be very like in pesos, right? Even if you are able to solve the problem, how much money you will get in maybe few rupees or few pesos.
फ्यूचर इन्वेस्टमेंट होल्ड करके अगर
Yeah,
इथेरियम भी 10 साल पहले रख देते
obviously,
तो
obviously. So that is the part, right? You have to find the correct whichever blockchain is doing that, right? And you're able to invest your mining power there. So just imagine the like kind of initially when Bitcoin started that 50 BTC or initial thousand of BTC, it would have done from the laptops only, desktops only. So your like kind of that point is very correct. Initial mining power required because the number of blocks are very few, number of miners also will be very few. The puzzle like solving, let's say maybe 1020, that can be done easily with a laptop. But as the block length increases, the puzzle gets kind of more tougher. Obviously, it will not be possible through a laptop. Yes, if you are able to find a blockchain right now in a nascent stage, somebody started an initial coin offering and you are part of that. Right now, maybe you'll get a, let's say that is certain kind in Samrat name, SAM, right? And if you get like 10 SAM or 50 SAM, currently the kind of value, real monetary value of that may be 50 paisa or 1 rupee. But if that blockchain is profitable and that blockchain actual has some value like Ethereum, right? Later on, you can become a millionaire, right? Most people have been like that in those initially invested there and their mining power.
Sir,
Yeah.
Samrat said one thing that initially the initial miners who are solving the puzzle, they are paid more as compared to the person who are solving the more complicated parts.
Correct.
So how is this? How will it doesn't set well? Like why? If the initial part is easy, why they are being paid more?
So basically, you are
compared to-
like kind of taking that risk, right? You are putting your effort in the beginning, right? You know that it might, like the Samrat was talking about, right? Let's say he creates a blockchain called SAM. Will you put your computing power there? Unless you say that I'll get some 1,000 rupees or 10,000 rupees out of it. Currently, if
Yes.
you put your 8 hours of effort, Samrat will tell, I'll give you 10 SAM. The currency is SAM. I'll give you only 10 SAM for each of the block you are solving, right? And but that SAM value in actual kind of life or reality might be few pesos or might have worthless also currently. Maybe 10 years down the line, like it happened for Bitcoin. The initial Bitcoin people like I think the first sales made was 2 pizzas. I think how much 20 BTC or something like that. And right now 1 BTC is Bitcoin is around 30 lakh rupees. Just imagine who bought those 2 pizzas with that Bitcoin 15 years
Yes.
back, right? That is the challenge, right? I agree with Samrat, but finding that who is obviously the same thing with the stock market also, right? Currently, there will be companies whose stock are 3 rupees or 5 rupees. I can put all my money there. If I know that 10 years down the line, their stock price will be 3,000 rupees. So same thing, same situation here. If I'm putting my
And
computing power,
yes, sir. These miners, they are not like ordinary programmers. They need to be something very high professionals or something.
no. You can, if you have an investment of 10 lakhs, you can be a miner. So miner is somebody, it is not that they need to program something. They just need a money to invest in computing power. See what happens right now, finding this random number is very difficult, right? Manually. So you'll be utilizing a software which will create this random number so that this hash is starting with 4 zeros. So that software is nothing but if I put it mine here. So the see once I click this mine of button, 4 zeros started, right? And the number is 28826. So how to solve this puzzle, right? By not knowing the random number. So obviously manually I cannot do that. I have to involve one computer, right? Currently in Bitcoin, these zeros need to be around first 19 zeros. The hash need to be in such a way that all the first 19 character has to be zeros. So the puzzle is tougher. So initially when it started, it might be 1 or 2 zeros or like this 4 zeros, right? The puzzle was simpler. I could have solved with a laptop. Right now, what happens with a laptop, it will take a few days or few months to solve that problem. So that's why I need a larger computing power and I need an investment for that. Larger computing power, electricity, right? And that is the investment from my side.
Yes.
So again, repeating. So each time we are creating this hash is nothing but information, the block header, the random number, which right now I just created, then the data inside the transactions, and the previous hash. Right, in this case, the block number 1, there is no previous block, so this is everything is written as 0, right? If I go to the next and I write certain transactions, right? B to F, let's say only there is one transaction, right? Now if you see what has happened, the previous hash is whatever is written here, this is copied here. So whenever I'm creating a hash here, right, the output message, right, it combines all the information available here, that is the block number, the random number which will be generated, the data inside this data is nothing but the list of transactions, and the previous block information. Previous block information has been encrypted into this hash, this 0040921117, which is here, right? So each block will have information about all the previous blocks, right? Because all the data in previous block has been encrypted into one hash. So when I'm creating a hash of block number 2, right, it also incorporates the information in block number 1. Obviously not the list of transactions. All the information is block number 1 has been converted into this hash, and this hash will be part of this block number 2, right? Now what has happened? Block number 1 is validated. Now all the miners, all the 45 of you along with me, I'm trying to solve the puzzle again, which will create this hash with 4 zeros, right? I can start putting number. Let
Sir,
me
these are
yeah.
hash were private key or the public key?
Here there is no private key or public key. Private key or public key will be where I'm making a transaction. Hash is just an encryption of. So here I'm not using my private key or public key, right? Here I'm just trying to solve the puzzle. Private key and public key will be, let's say B is putting money to F, right? So that time we'll require the private key of B, public key of F, right? And what is that we'll discuss later. So private key and public key is required during transaction, not for the creation of hash, at least in the block, right? So that is required when any transaction, particular transactions are happening. That I'll come back later on. Okay. So now what happens? Now I have to solve the puzzle. So what I'll say, let me be intelligent, because last time 28826 created 4 zeros, whether it is creating no. So like that, I'll again, like maybe one number before that, like that I'll keep trying, right? Obviously manually it cannot be done. I have to again use algorithm to mine it. So the number is 27589, right? So this block is now validated. So like this, blocks keep being created. So now what is the miners do? So like, so think of all these 43, 44 students as miners, right? Each of us trying to solve our puzzle in our laptop, right? Whoever is able to find this random number first, right? He becomes the winner, right? And once he does that, okay, I have found out this number, right? 27589, right? So this he will circulate across the kind of all these 43 people, right? And they will verify it. How do they verify? They just put this number in there. Like you just some of you who have not kind of put this mine button, right? Just write down B hyphen F, and then put this number, whether you are able to get 4 zeros, right? So basically all the other miners, right, just verify that whether I am telling the truth or not, right? Then if 51% agree that yes, I'm telling the truth, then the block is verified and will be added to the blockchain. That is the mining part.
Sir.
Yeah. Go ahead.
Sir, in my system, Nonce is showing that after I press the mine button, it's showing 68616 with result 4 zeros in the starting. But sir, in your system, it's showing that 27589. But sir, this is not same, sir. I think.
You have written the same thing, A/B, A/C, A/D.
No, sir, I am talking about the block 2, second
yeah,
block.
Block 2 again have this information, right? So all the information, if your block 1 is different than block my block 1, right? Results won't match. Do
Sir,
one thing.
My block one and your block one is same, but block two are means the nonce part is different.
So you have put A to B, A to C, A to D, then you have mined it.
Yes, sir. 28826.
Then you put B to F, then you mined it, right?
Yes, sir.
And there is no caps lock, there is no other things, right?
No, sir. No, sir.
Can
It
anyone
is
else
showing
confirm?
68616.
yes, sir. 68616 mine also.
No, you don't mind. You just put this number and try to get the data. Sorry, validate it. So some of you have not mind. Okay, let's try to do it for block number 3, right? Okay, block number 3 will change. Okay, so okay, do one thing. Remove every information there. Okay, let us try to do it block number 1. Don't keep any information, right?
Sir, I got the same as you got.
Yeah, ideally that should be the case. I'm not sure. So do one thing, remove every information, right? All the information what you have written. Let us say there is no list of transactions. It is a blank document, right? And I'll mine it, right? So 11316, right? So
I
whatever,
think they might missed the space in the like.
yeah,
You
I
were
think there will be
written
certain
A,
change.
B, then space. That space they might miss. That's where the difference came.
Yeah, so let us do it such that there is no transactions here, and we'll try to validate it. So what happens right now? I have this nonce created, right? 11316, right? Then I'll and this block which has been hashed, right? 40157, that has been written here automatically, right? So what does it means? All the information of block 1 got encrypted into one hash, and that encryption is right now part of block number 2, right? Now what I'll do, others please do not do it, I'll just mine it. So I got a number of 35230. So others who have not clicked on that mine button, just put 35230 in the nonce, right? And see that whether you are getting the hash 4 zeros and 1 2 FA.
So
Yes, sir.
So this is the verification part. What happens, because as a miner, I was able to mine fast. Let's say my computer is faster. So what I will circulate in the blockchain, right? So I have solved the puzzle and the solution is 35230. So if 51% of you, if 23 or 22 students able to put the nonce and found the hash, like correct hash, right? Then you will agree, you will say that yes, block is verified. Then block will get added to the blockchain. So that is the puzzle part. Finding a random number, finding that nonce, which will create that hash with certain zeros. Right? For this demo, it is 4 zeros. For actual blockchain, it will be little tougher, 19 zeros, 18 zeros, like that.
Sir, for the first 2 3 blocks, sir, the data is completely same. I mean, it's blank.
Yeah.
But the hash is different. So is it same for everything? Like every block, even the data is same, it will have different hash.
It is not,
code.
yeah. So like I said, the hash is not created only out of data. Hash is created out of 4 or 5 things. So this hash is a combination of this block number 2, nonce, the random number you are creating, the data is same. The data here is blank, here is also blank, right? Then the previous hash. So combination
Okay.
of these data, like combination of previous hash, the data, the random number, and the block header, all these combined, then it get hashed to this number. So what you are telling
Okay,
in
sir.
this past 3 block, the data is same everywhere, but other parts are different, right? The block number is different, nonce is different, previous hash itself is different, right?
Sir, as we talked, there are might be thousands of miners, and if I got the correct nouns, and how I will say to others because they all were unknown to me.
Yeah, so that is something called a communication layer in this P2P network, right? So, so obviously I don't know Samrat, you might be a miner and I might be a miner. So your address is again a cryptographic, like that is that has, right? That is certain alpha numerical number. My address is also certain alpha numerical number, right? I don't know you, you don't know me. But what happens once you find this random number, right? So that random number, this random number is created by this address, right? Which has solved the puzzle, right? That communication will be transmitted to all the miners who are present during that block creation over that communication channel. So here I'll not know that, okay, Samrat has created or who has created, but I'll know that this address has created that nonce, right? Then by using that nonce, if I'm able to verify that, right? So if I just click on that distributor, right? So this is peer A, right? This is peer B, this is peer C, right? So these are, I think about 3 miners, right? Peer A is one miner, peer B is another miner, peer C is another miner, right? For all the information what the peer A is getting, right? Every time, let's say peer A is able to solve the problem. What he will do? So he'll send this random number across to peer B and peer C. Peer B and peer C will put that random number into this algorithm to find out this hash. If they find the correct hash, either both of them will tell or one of them will tell. Let's say peer B says, yes, you are correct, you have solved the puzzle. Peer C says, no, by because there is a majority, right? Out of 3, 2 people have said yes, right? You and peer A and peer B. Block will be created and we'll go ahead.
So the
Was that
communication channel you mentioned is default with that blockchain software, or it's something else?
yeah? So
They
that is
need
one.
to.
That is there are actually 5 layers in blockchain: the infrastructure layer, the security layer, then the communication layer, then the application layer, right? So these three happen like the transmission of data that who has created this random number or who was able to solve that puzzle happens over that communication layer.
So all the miners can see each other's peers.
Addresses they can see, but they cannot know who is that or where he is from, whether he is from China, America, or whatever location, they will not know. But I know that your there is currently 10,000 addresses, 10,000 miners who are working on the like creating a block. So your address will be
Like,
basically
sir, as we see, there are 3 peers in here. So like 3 different miners are working on it. So
yeah,
peer 1A can see the peers what peer C is doing.
no. What he or she is doing is not able to see. He will only know that, okay, this the address of peer B and address of peer C. What you are doing in your laptop and all those things, that is up to you. As a miner, I will only know how many people are mining, right? There are 10,000 miners, or like currently there are 5,000 miners, and what are their addresses. But I'll not know exactly who are you.
Sir, one doubt, sir.
Yeah,
Sir, uh, if we are sharing the code which we have cracked, right? The nonce code.
Yeah.
So in case a miner got to know about our hash, so is he able to see our whole information?
Has about what, like the block has?
Yes, sir.
Block hash is public, right? You can also know what is the current hash of any block.
So we have both the thing. So he can crack, right?
Yeah, but you have created, right? So the idea is who was able to solve this faster, right? So let's say Satyaswarup, you have a better laptop, right? You are able to find that random number fast, right? And it has been communicated over the network, right? So right now, if I am getting that number, I cannot say that I have solved. So it is basically how many of you are solving, that is not the problem. Who is solving it fast? If
Okay.
as a person you are able to solve it first, the reward will go to you. So because the computing power is that much required, so what happens? Most of the people kind of arrange their computing power together. That means let's say 45 of you will link your computing power together. That is known as a mining pool rather than a single miner. If you see a lot of if you go to that blockchain explorer and look into the Bitcoin or Ethereum, right? Single miner getting a currently it is kind of impossible. Most of the times it will be a mining pool, big corporations investing a lot of money, right? So the idea of where Bitcoin started has been defeated, to be honest, right? It started with a democratic process. Again, it has been kind of getting to this corporate where the more muscle power, more computing power guys, so get more money. And to avoid that, there are other mechanisms. We'll discuss that. People are started moving from this kind of solving this kind of puzzle, because this is just imagine this is a wastage of effort, right? This is not a value addition. This is just to show that okay, somebody is solving a problem and he will get a reward. And what problem is solving? It is basically finding a random number, right? So this basically is not a very ideal way to kind of put your resource or effort. So that's a lot of blockchain are moving into other mechanisms, right? So those are the things we'll discuss. This mechanism where you are working something, right? Known as proof of work, right? Proof of work. You are doing some work, and that is my proof that I have solved this puzzle. That creating that nonce, that is my proof. And I'll send this proof across all the miners, and they will, if 51% of them verify that yes, the nonce is correct, right? Then the block will be created and we'll move ahead, right? So that is the kind of basics of blockchain work. Any doubt on this? Okay, so do one thing. So I have just like we have discussed these 3 or 4 parts, right? Hash, block, blockchain, and distributed. Distributed is nothing but it is just showing number of miners, right? Peer A, peer B, peer C are the miners, right? There is something called tokens, right? Tokens are something about the transaction part, because actually the transactions being recorded in these blocks, right? We'll
Sir,
discuss
one
that.
doubt.
Yeah, go ahead.
सर peer A का last block और peer B का first block मतलब they are sharing the previous मतलब उसका previous same रहेगा?
Peer A has the same copy as peer B and peer C. This is the
Okay,
same
no,
blockchain. Yeah.
Okay, sir, here peer A का block 2
Okay.
and
Peer A block 2.
yeah,
Okay.
yeah, we can see in previous it has the address of ये block 1.
Correct.
Yeah.
002
So,
157.
So are they connected? Peer A, peer B. मतलब peer A का last block and peer B का first block.
No. Peer A, like I said, think about the notebook, right? So peer A
Yes,
has
sir.
this notebook. This copy of this notebook is also with peer B. This copy of this notebook, there is a single notebook, right? The copy is being distributed across peer A, peer B, peer C. So it is not that okay, I'm matching with this. So this is exactly same as peer B. If I'm making as a person, let's say you make some changes here, right? You mind it, yes, and sir, you mind it. You will say that okay, right now this is my block, right? But it is not true, because the other 2 copies are different than you, right? If you are able to
Yes,
convince the peer B that okay, make the changes, then majority will be yours, and you will say that okay, right now this is the actual transactions.
Okay.
But with
So
this,
if the majority got,
yeah,
if the majority got approved, then is it that like automatically all the copies will change?
all the copies, previous copies. So can you please repeat your question?
So like A did some change in block 2 and he convinced to peer B to change in the block 2. and they both got agreed and they got changed. That changed like as
correct,
both
correct,
changed,
correct,
it means the majority changed.
correct, correct.
That means the PRC ka block 2 will automatically change what the other did. As
So
the
what happens
majority
actually, there is some concept called forking, right? And it actually happens, right? So the longest chains continue, right? Right now what happens, these two persons agreed and their copies match, right? So what will happen when block 4 is getting created, right? Whatever information these two persons have, these blocks, right? This blockchain will continue. The other blockchain will stop here. The person, the information what he or she has, the copy of this blockchain, right? Because he has a different information and it has minority, right? It will not no longer continue. So if this person wants to continue in the blockchain, right? So wants to mine it, right? He will get a copy of this blockchain, the like kind of majority of blockchain, and will continue with that.
If he had done with the 7 blocks, if he want to go for the 8th block, he have to approve the copy.
Here only 3 blocks are there, right? There's a 4th block. I'm talking about the 4th block.
Yes.
Okay. Here how many? 5 blocks are there? Yeah. So when working on the 6th block. So if I have 5 blocks, right? Let's say right now, these are the 5 blocks, right? What will happen? Peer A will say, peer A has somehow known that who is peer B and convinced him, right? So convinced him to, what is this, block 3, right?
Block 2.
So convinced him to make some changes, right? Block 3 only I changed, right? Also I changed. So what is happened now? Block A, sorry, peer A, this minor A, let's say some of you, one person of you, make some changes in transaction 2 and 3. So he mined all the previous blocks again, because the changes has to be actually I had already mined it, right? So now what we'll say, make those changes to peer B, and peer B also agreed. So he got certain outside money. So he agreed and he created this copy. Right. So what will happen now? Your peer A copy and peer B copy is matching, right? So they will say that, okay,
Yes.
we have the majority because there are only 3 minors, right? So in majority has the same copy, right? They will continue with this whatever copy they have. Whatever copy this person peer C has, right? That will be abandoned. If the peer C wants to continue with creating block 6, right? He has to take this copy, right? And continue with that. He has to abandon whatever information he or she has, right? So again, it is a majority wins. So to answer your question, yes, if the majority are corrupt, then the corrupt information will get incorporated. Wrong information will get incorporated.
Yes. Thank you, sir.
Okay, so I've
Excuse me,
taken,
sir,
yeah,
actually we have classes.
yeah. Please go ahead and go for your next class. Please go through the Bitcoin white paper. I have asked you to solve, kind of at least put a individual opinion about that paper, right? This is the individual assignment you have to complete by next Monday. Maximum 1 page. Don't just summarize the paper. Whatever you understand, right? It might happen that you just understand 20% of it. That is okay, because we're going to discuss that in detail. Whatever you understand, 10%, 5%, 20%, right? Write in your own words, right? It is, I think, 7 or 8 pages. Complete that assignment by, and I think the time is next Monday, right?
Yes, sir.
Chalo.
Excuse me, sir.
Yeah.
Sir, I have missed my attendance.
Roll number?
Sir, 296.
296. Okay.
So
Thank you,
280
sir.
I
total.
also missed my attendance, sir. I said, sir, roll
Yeah, I've
number
taken yours.
89.
289. Yes, I've taken yours. Anyone else?
Sir, 284.
284. Okay. Anyone else?
So I told you back then 272.
272. Yes, I have taken yours.
Thank you, sir.
सर
Yeah.
सर एक कंफ्यूजन है सर, कंफ्यूजिंग डाउट थोड़ा एक
Yeah.
था
Yeah. Tell me. Others
सर
can leave.
आपने
Yeah.
बोला कि
Yeah. Good.
सर आपने बोला कि ये डेमो ब्लॉकचेन है जिसपे कि हम लोग का हैच आएगा 4 जीरोस पे, पर हम लोग का जो ओरिजिनल है उसमें हैच आएगा 19 जीरोस में।
There is no
और सर
original.
ये
There is kind of there are many blockchains. So what I was talking about the Bitcoin blockchain. Currently, Bitcoin blockchain, the puzzle is
19,
yeah.
yes sir, so I got that, but my doubt is sir, in order to get this hatch and we want a random number in nouns, and
Yeah.
that we can find that after clicking in mine.
Yeah.
If we press this mine button, then automatically that random number is showing in nouns column.
Correct.
So तो सर ये मेरा ये डाउट था कि मतलब ये तो हर कोई माइनर कर सकता है ना, मतलब कोई भी आएगा रैंडम नंबर जैसे फाइंड करने के लिए माइन का बटन दबाएगा ऑटोमेटिकली आ जाएगा, तो सर ये माइनर का फिर काम क्या हुआ, तो हर कोई माइनर बन सकता है, तो फिर इसमें कंपटीशन कैसे होता है माइनर को, मतलब उसको
Yeah.
काम
So
कैसे करते हैं सर?
correct. So finding a better algorithm which will find faster, right? See, you have not written that code, right, which is generating this 4 zeros. If I don't put this mine button, can you find this random number? Because I have given you that
No,
demo,
sir.
you are just clicking that mine, so you are finding that
Yes, sir.
zeros, right? If I say, Sagar,
Random.
don't use that mine, you find on
Okay.
your own. Use any internet
sir.
or anything, you use it now. Can you do that?
So it will be very difficult for me
Yeah,
to
so
find this
exactly.
number.
So that is the part of a miner, right? So they have to either create an algorithm which is solving the problem faster, and obviously you need computing power. So this laptop, it will take few seconds to find that, or milliseconds to find that 4 zeros, right? But I cannot find a hash with 19 zeros with this laptop processing power. So you need, so
Okay.
miner needs two things: computing power. Second is the algorithm. So the algorithm which is showing in that demo, that person has written that algorithm, right? So that
Acha.
is his kind of whatever trademark or the kind of confidentiality, right? If you are able to write an algorithm which will find a 4 zeros faster than this algorithm, that is your kind of capability, and you will get reward for that, right?
Mr. You are saying that this mine option will be not showing to them,
Yeah,
to
yeah.
the
So
miners.
obviously that if that is shown, so everybody can do it, right? So that mine, you have to create that algorithm, right?
Okay, got it, sir.
And
Thank
the
you,
better the algorithm, the like better result, the faster results you'll get, and you'll get rewarded,
Yes.
right?
Okay.
Chalo, any other question?
No, sir.
Okay.